All right, so the James Webb Telescope, it's done it again. This time, it's found a galaxy, and this galaxy, it's from way back, like about 1 billion years after the Big Bang. And get this, there's something not quite right about it.
Not quite right, or maybe perfectly right, depending how you look at it.
Okay, it got me there. So what's so strange about this galaxy?
It's faint.
Faint!
Yeah, faint.
Well, I mean, a lot of galaxies are faint, right? Especially the ones that are really far away.
True, but this one, it's glowing in the dark.
Glowing? I thought you said it was faint.
It is faint, but it's glowing.
Yeah.
And not from its stars.
Hold on a second. You're saying this galaxy is bright, but not from its stars. How is that even possible? I thought stars were what made galaxies shine.
You're not wrong. Typically, starlight is what we'd focus on. It tells us how old a galaxy is, what it's made of, all the good stuff.
Right, like a cosmic fingerprint.
Exactly. But with this galaxy, GSNDG 9422, or 9422 for short,
Catchy.
the gas is so bright, it's almost drowning out the starlight.
The gas. You mean like clouds of space dust and stuff?
Well, not exactly dust, but yeah, the
yeah.
gas between the stars. It's putting on its own light show.
Okay, now my head's spinning a little. How do we even begin to understand what's going on if the usual methods are out the window?
It's tricky, for sure. It's like trying to have a conversation at a rock concert, you know? Too much noise. But that's where the galaxy's spectrum comes in.
Spectrum. You're losing me a little bit.
Imagine if you could take a deep breath, and as you exhale, every single element in your lungs sings its own little song. That's kind of like a galaxy spectrum. It breaks down the light the galaxy emits and lets us see what it's made of.
Okay, I kind of get it. So, what's 9422's spectrum telling us? Is it a symphony, a pop song, heavy metal?
I'd say it's more like a scream.
A scream, like something's wrong.
Not wrong, just intense. The astronomers who looked at the James Webb data, they actually used the word weird to describe it. They even made a graph comparing a typical galaxy spectrum to 9422's. You can practically see 9422 waving its hand, yelling, "Look at me, look at me."
All right, we get it. The gas is putting on quite a show. But what's making it act up like this? And how does any of this help us understand the early universe?
Well, we know the early universe was kind of a wild place, right?
Oh yeah, total cosmic free-for-all.
Hotter, denser, way more chaotic than anything we see today.
Right.
The team looking at 914E2 thinks that it might be jam-packed with a population of stars, so ridiculously massive, so incredibly hot, that they're basically superheating the gas clouds around them.
Okay, hold on. How hot are we talking? Because my oven gets pretty toasty, but I doubt it could make an entire galaxy glow.
Think about this. A typical hot star, maybe 70,000, 90,000 degrees Fahrenheit, somewhere in that range.
That's pretty darn hot.
These stars
Yeah.
could be double that, over 140,000 degrees, like the core of a star decided to throw a pool party on the surface.
Okay, that is seriously hot. So these megastars are basically acting like giant cosmic blowtorches, just blasting the gas around them with energy.
Pretty much.
But here's what gets me. This galaxy, it formed, what, about 1 billion years after the Big Bang, right? So how does that connect to the very first stars in the universe, the ones that were around even earlier? I'm a little lost on that part.
Now that is the million-dollar question, and it's what makes 913-400-202 so incredibly fascinating. This little galaxy might just hold the key to understanding the very first stars, the ones we call population 3.
Population 3 stars, those are like the universe's VIPs, right? The ones we talk about, but nobody's ever actually met.
That's it. The universe's founding fathers, if you will. Pure hydrogen and helium, straight from the Big Bang. No fancy stuff yet. We're talking giant stars burning bright, burning fast, gone in a flash, relatively speaking.
Okay, so gone in a flash, meaning they were long gone by the time our galaxy, 90422, even came on the scene, right?
Hundreds of millions of years for.
So how can a galaxy that's a late bloomer, relatively speaking, tell us anything about the universe's very first stars?
Well, that's the missing link part. This galaxy, with its supercharged gas and all that, it's like an echo. It's not that 9422 itself has those original stars, but it's acting in a way that those early stars likely influenced. It's a bit like...
It's like finding a dinosaur footprint, right?
Yeah.
Not the dinosaur itself, but you can learn something about how it moved, what it was like back then.
Perfect analogy. We're using 942E2 like a cosmic Rosetta Stone. This glowing gas. It's a message, a clue, to decode the mysteries of population 3 stars and how they shaped everything.
What kind of mysteries? Spill the cosmic tea.
Well, imagine figuring out how the very first stars died. Did they go out in a blaze of glory, exploding as supernovae and seeding the universe with the building blocks for everything else?
Like each generation of stars passes the torch, right? Carrying on the legacy of the ones that came before.
Exactly. And 9422 is giving us a peek into that story, a chapter we haven't read before. It's like finding a lost scroll, revealing the secrets of the universe's origins.
Okay, that's seriously cool. But let's be real, most of us, we're not staring through telescopes every night. Why should this discovery matter to, regular folks?
I get that, and it's a question I love. It's why we explore it all. Discoveries like this, they remind us that the universe is so much bigger, so much stranger than what we can see just looking up. It makes you think.
Like that feeling when you look at the night sky and realize how vast and mysterious it all is?
Exactly. And beyond that, these discoveries, they might just lead to things that directly impact our lives, maybe even help us solve problems here on Earth. New technologies, who knows? It's all connected.
Okay, I'm convinced. But going back to this missing link thing, if 9422 is the bridge between those first stars and the galaxies we see now, what's that say about how the early galaxies formed? Did they all go through this superheated phase?
That's the billion-dollar question, isn't it? It's thrown a bit of a wrench in things, honestly. Makes you wonder if maybe, just maybe, this crazy gas-dominated phase was more common in the early universe than we ever thought.
So instead of being a total weirdo, 9422 might just be showing us how galaxies used to roll back in the day.
Exactly. And if that's true, we might need to rethink our whole understanding of galactic evolution. How these galaxies cool down, when did stars take center stage, and how do they eventually become the majestic spiral and elliptical galaxies we see now?
All right, now you've got me hooked. We've got to get to the bottom of this. So it's like we're peeking into the universe's messy teenage years when everything's changing and it's, well, kind of awkward.
Perfect way to put it. Those early galaxies were probably full of surprises.
And that's what's so great about astronomy, It's like a never-ending detective story where we get these little clues, these hints, and we have to put it all together, figure out what happened billions of years ago.
And the best part is, with telescopes like James Webb, we're only just starting to uncover these secrets. Who knows what else is out there waiting to be found?
Okay, so speaking of those secrets, if this one little galaxy is telling us that our picture of the early universe might need a little retouching, what other big surprises could be lurking out there?
Well, for one, we need to figure out just how common these superheated galaxies were.
Yeah.
Was 9422 a total fluke? A one-hit wonder of the early universe?
Or was it like the first one at the party who dared to be different, and then suddenly everyone else like, hey, wait for me, I want to glow too?
Exactly. And to find out, we need to look for more of them. More galaxies with that telltale gas shining brighter than their stars.
More cosmic teenagers running wild in the early universe. So what else is on our to-do list? What other mysteries is 9422 throwing our way?
Well, we've talked about those massive stars, those cosmic blowtorches heating everything up. But what if there's something else going on, too? Something we haven't even thought of yet?
Okay, now we're talking. Spill the cosmic beans. What other wild possibilities are on the table?
Well, it's still early days, but some folks are saying that maybe, just maybe, those supermassive black holes, the ones we think are at the heart of most galaxies.
Yeah, those things are intense.
Exactly. Those black holes could be playing a role in all this, too. Their energy, it's off the charts.
So now it's a real party. Black holes, megastars, glowing gas. Who else is coming to this cosmic bash?
Well, who knows? Maybe even dark matter's involved somehow.
Dark matter, now that's getting seriously mysterious. But hey, that's what makes this all so fascinating, right? The universe is full of surprises, and the more we learn, the more we realize we don't know.
Couldn't have said it better myself. And that's what I hope you take away from this deep dive, this little galaxy 9422. It's a reminder that we should never take our understanding of the universe for granted.
So true. Even the faintest, seemingly unimportant things can hold incredible secrets.
Exactly. There's always more to learn, more to discover.
So to everyone listening, keep looking up, keep asking those big questions, and never lose your sense of wonder. It's what keeps us exploring, discovering, and unraveling the mysteries of the universe, one deep dive at a time.